Hello viewers, my name is Raj and welcome back to my YouTube channel. So today in this video, we are going to discuss this particular problem, which is unique paths named numbered as 62 in Leetcode platform. So it is a medium category problem and this is a new video in complete placement preparation series. So before I start this video, I would like to request, if you haven't subscribed this channel, please subscribe it, like it, comment it and share it among your friends so that it gives me extra motivation to bring more such stuff on YouTube. So let's start our today's content. So we are given a grid of m cross n, where m is the number of rows and n is the number of columns. So we have a robot which is standing at the left upper corner of this particular grid, so which is 0 0, and it wants to go at the bottom right of this particular grid, and the conditions are that it can only go in two directions, which is towards its like the downward direction and towards its right. So there is no way possible we can go across this particular grid like this. We are only allowed to go down and towards the right. Also we can't go towards the left direction or the upper direction. So right, so we have to find the number of paths that the robo can have or robo can take, such that it can reach the finish line. Right, so if I take this particular example, robo can go up from this way to this way, from going down first and then going towards its right. Also the robo can take paths such as like going 2 blocks towards the right, then 2 blocks down, and then again right for 4 blocks. So these are all possible combinations. So the task is to find all such possible paths that a robo can take, right? So how to solve this particular kind of a problem? So if we simply see this, we can build a recursive solution to solve this problem. So what can be the recursive solution is, so we'll take the first approach, which is a top down approach. So we will have the big problem and then we will try to solve it by solving the smaller problem. So here I can see that we have around 4 rows and 7 columns, right? So we have a configuration of 4 cross 7, right? So the recursive relation, what I can build is paths m into n minus 1 plus path m minus 1 n, right? So if I take this particular sum, then I can get the total number of unique paths for, like, starting from, this is a recursive relation, right? So it is a generic term. So if I replace the values, what I get is 4, 6 plus 3, 7, right? So if I solve this particular, if I pass this particular set of values to this particular function, which is a recursive function, and 3, 7, and whatever the result I get, I will add them up so that I will get the total number of unique paths, right? So, but we don't know the value of this particular set of values. We don't know the answer of this particular set of values. So what it will do since it is a recursive code, it will again boil down to, this will again break up into 2 paths, which is 4, 5 and 3, 6. Okay, so and similarly this will also break down to 3, 6 and 2, 7. Similarly, it will break down. It will make a big tree. So this will be a big tree, something like this. And at one point it will reach the bottom value, which will be either 1 1 or 1 2. So basically it will reach this particular set of values where the trivial solution exists. And so the base case would be that if I want to reach this particular cell, I can reach it in one way, right? Because there is only either this way, and similarly for all such values I have, for this particular set of values I can reach them in one way only, right? So since I am starting it from the this particular cell, the entry point is this, so I can only reach there by only one way, right? So this way if I get the solution for this particular, I have the solutions for this particular set of values, then I will simply go up in the tree, and then I will at the end I will get this answer for this, and then I will get the final answer. But this is a very no very time consuming thing, and this will have a time complexity of around 2 raised to power n, where n is the number of elements, basic to be precise, or the number of problems that we are dealing with. So here this is the one problem, this is one problem. So similarly there will be a 2 raised to power n sub problems, right? And the space complexity will be around mn. So mn is nothing but your total number of values. So the space complexity is fine, but time complexity is way too high, and we have to reduce that. And also there is a problem in here that we are computing 3,6 and 3,6 like 2 times, and if we go in deeper if we go deeper in this particular tree, we can see that we are calculating the same values again and again and again. So we have, this is kind of a redundant thing when we have to do something about it. So let's go towards the next approach. So there is one more approach that we can take is using combinatorics. So since we have m rows and n columns, we can find we have this particular formula of combinatorics. So if you solve this particular formula, you will get your answer. But this is fine mathematically, right? But if I want to calculate, if I want to implement this thing in a computer or in a program, then factorial is a very expensive operation, and we can't afford to have too many expensive operations in our program. And if I see carefully, I have 3 factorial operations to be deal with. So this is a messy thing, and often like factorial programs, it is become very, it can be very hard to implement a factorial code, what I can say, an efficient factorial code whenever you are trying to solve this problem. So this is one approach, but I will have a better approach that can solve our problem. So moving next, there is an approach known as dynamic programming, which is also known as DP. So dynamic programming is one such approach in which there is a guarantee that we can reduce our time complexity from 2 raised to power n to a very good time complexity, let's say log n, not log n, n log n or n square. So if we can manage to get somehow reduce the time complexity from exponential to logarithmic or like n square, then it is a very good thing. So dynamic programming helps us do that. So what dynamic programming says is, it is a bottom up approach. So bottom up in the sense, and we will start from the base case and then we will gradually build up. So when we are trying to build gradually up from the bottom, so what we are doing is we are saving the states and we are not computing it again and again and again. So if I see in the recursive solution, I'm computing 3,6 multiple times, but in bottom up we won't be doing that, because we are going to save a particular state that we are computing, and then we will use it in future purposes. So if I see in this particular thing, what I have is initially is, I know that there is only one way to reach here, 1 1 1 1 here 1 here 1 and so this is the base thing that we know, that there is only one way to reach all these particular cells. So if I'm at this, but if I want to reach this particular cell, right, if I want to reach this particular cell, what are the ways that I can reach? I can reach from the top or from the left hand side, which is, since we are only allowed to go right hand side, so from here I can only go towards this or this. So since I know that I can reach this particular cell using one way, this is also one way. So what I can simply add them and I can write 2. So 1 plus 1 is 2. So, and if you even logically see how I can reach this particular cell, either this way or this way. So this is true, right? Similarly, for this particular cell, I can reach this particular cell via this way, or this way. So it is 2 plus 1, 3, right? Similarly, this is 3 plus 1, 4, and 1. So if you gradually compute, you will at the end you will reach this particular cell, and whatever the value in this particular cell is, this will be your answer. So what we have to do is, at any point of time, let's say this matrix is known as M. So whenever we are computing M of I comma j, where j is the column pointer and I is the row pointer, so what we have to do is, we have to simply check what is the value of this particular M minus 1 plus M of j minus 1. Right, so whatever this value will be, this will be your particular cell's answer. And similarly, at the end you will reach the end of the particular matrix, and whatever the value at this particular point will be, this will be your answer. So the time complexity is n square, and the space complexity is also mn. So mn, if you can simply write this n square. So often we can reduce this particular n square to n, or mn to n, so by reducing the size of this particular grid. So there is a hint. So this is a task for you guys to do. So you can simply use the column size, which is n. So you can simply make the DP matrix of the size n only, and there is a small logic that I keep up to you guys to solve it, and please comment it down in the comment section if you find that particular solution, or else I will give it in the comment section only. So that's all about the approaches. So I will try to code this particular DP solution in the Leetcode platform. So also there is one thing to notice: whenever you are implementing a DP solution, we have to give some extra margin to the base case, because the base case is since we are making a generalized code. So for whenever we are calculating the values for this particular cells, there is no way we can have this particular the left cell and the upper cell, right? So for that we have to make an extra row and extra column, which will have 0 values, so it won't make any difference. Okay, so let's try to code this thing. So I will keep the so what I will make a DP, which is a matrix. So I will use list comprehension 0 for I in range n, for I in range for so this will be j, this will be I range in m. So m rows and n columns, and I will keep 1,1 as 1. Now I will try to implement the DP code. So for I in range m, 1 to m, and I will go m plus 1. For j in range, so this will I have to since I have to keep one extra row and extra column, so I have to plus 1, I have to add plus 1 to this n and m whenever we are creating the DP array. Similarly, n comma n plus 1. Okay, so we have to check if we are at the first cell or not. Since we are assigning the value of 1 at 1,1, so we won't have to iterate to that only. So I will have if I is not equals to 1 or j is not equals to 1. So this will return false. The condition will false for 1,1, or except that all the for all the cases it will go inside this particular if statement. So for that particular case, I comma j equals to dp I minus 1 j and dp I j minus 1. Right, so this will do the trick. Let's return dp of minus 1 minus 1. So let's try to run this code and see if this works or not. So yes, this is working fine. Let's try to submit this thing and see how much it is efficient. So this is 60 faster than 61% and 86% better than the other in terms of memory. So in both in time and space, this is working very fine. So you guys can try. So if you try to change a little bit in that in this particular code, you will get the more than 85% as well. So I have got that in my previous submission. So that's it in this video, guys. So thank you for watching. Thank you for subscribing. Thank you for liking this particular video. Comment in doubt so that I can get to know what all more such problems that I can bring up to you. So till then, this is Raj signing out.